My name is Chima, and today I'll be solving Leetcode problem number 21, merge two sorted lists. So for this question, we're given the heads of two sorted linked lists, list 1 and list 2, and our goal is to merge the two lists into one sorted list. And the list should be made by splicing together the nodes of the first two lists. And at the end, we want to return the head of the merged linked list. Alright, so for this problem here, goal is to merge two things into one thing in sorted order. That's how you should see it. So two lists into one list in sorted order. So with linked lists, we iterate through them using a pointer. So why don't we have a pointer that points to the head of the first linked list and a pointer that points to the head of the second linked list, and then we can create an external node or a dummy node to represent our results. And to this external node, we want to add values to it based on the order in which we iterate through both lists. So we're going to iterate through both lists based on the comparison of the values at each node. For example, here, like when we compare the red list to the purple list, on the first node, we see that they're both equivalent, so it doesn't really matter which pointer we move. So let's just say we're going to move the purple pointer on equivalent. So we're going to move from 1 to 3. And then we compare 3 and 1 again, because remember they said the lists should be made by splicing together the nodes of the first two lists. So we now compare 3 and 1 together. And we see that 1 is less than 3, so then we're going to add 1 to our result here, right? And then we compare 2 and 3 together, and 2 is less than 3, so we're going to add 2 here. Then we move the pointer here in red to 4. Then we're comparing 4 and 3 together. 3 is less than 4. We're going to add 3 to our results. And then we compare 4 and 4 together. They're equivalent, so it doesn't really matter which one we add. Let's say we add the red one. Then we compare, then we exhaust this list, right? Once we exhaust this list, we know that there's only one node left, so we can just add that to the end of our results. And that's it for this problem. We should have the entire result. So let's go ahead and solve that. I'll write that in code. So I said here we're going to need one pointer for list 1, P1, and P2. P2, say P1 equals list 1, P2 equals list 2. I'm going to say dummy node equals list node, initialize with 0. Say dummy node pointer equals dummy node. Okay. So now let's go through our linked lists. So we're going to say while P1 and P2, right? So while we haven't exhausted either of our linked lists, we do this. So while P1 and P2, if P1 the val is less than P2 the val, okay, yeah. So if P1 the val is less than P2 the val, we're going to create a new node. So new node equals, or rather, we don't need to create like a new node here. Like we're just splicing together the nodes of the first two lists. So what we can do here is our dummy node pointer dot next equals P1, right? Then we're gonna move P1 equals P1 dot next. So say a dummy node pointer dot next equals P1, then P1 equals P1 dot next. So before we do that, say dummy node pointer equals P1. Or actually, let's not do that. Okay. Then else else. So this is the case where it's the opposite. Say less than or equal to that. Let's say here p2. p2 equals p2 then next. Alright, and then after each iteration, what we need to do here is that we need to move our dummy node pointer, right? So we can properly update it for the next iteration. So we just do dummy node pointer equals dummy node pointer dot next, right? So then our dummy node pointer is prepared to be updated for the next iteration, right? So what we're doing here is that we're iterating through both links lists, like while they're both not exhausted. We're checking if the pointer in our first list is less than or equal to the pointer value in our second list. If it is, we're gonna add, or we're gonna point our dummy node's next pointer to be p1, like in the case that p1 value is less than or equal to p2. And if it's not, we're gonna set it to p2, right? And after we're done with that, we're just gonna move our dummy node pointer to the next stage in its or rather to the next link in its list to prepare for future updates. Then after we're done with this, right, like there's a chance that we haven't exhausted either of the lists, right? Or we haven't exhausted one of the two of the lists, right? So like imagine list 1 in this case was shorter than list 2. We would exhaust list 1, but then there's going to be one element left in list 2 to be added onto our result. So what do we need to do for this? You can do a simple check. If p1, then we need to say dummy node pointer the next equals p1. If p2, dummy node pointer the next equals p2. Right, so all we're doing here is just adding the remaining elements if either of the lists weren't exhausted while we did our initial iteration, right? And then after we're done with that, all we need to do is return dummy node.next. And if I didn't do anything wrong, they should work. Yep, so all the 3 test cases passed. And let's submit the code, see if it's accepted by Leetcode. And it's accepted. And let's do some analysis for the time and space complexity here. So for the time complexity, we have so we're just iterating through our linked lists. On each iteration, we're doing an O of 1 operation where we just move pointers around. And similarly to after we exit out of the loop. So time complexity here is going to be O of n due to iteration. And our space complexity will be O of 1. Why? Because we're splicing the list together. We're just moving pointers around. We're not exactly creating a whole new data structure here. So O of 1 time complexity, splicing two lists together, moving pointers around. And that solves it for this question.